Enrique now is here to talk about TensorFlow for mobile developers. So enjoy.
Thank you. Well, thanks everybody for being here. As Hampus say, I'm going to talk about TensorFlow for mobile developers, which is this maybe hot topic where everybody tries to see if it can fit on a production app or not. And yeah, well, it was my second time in Oslo. I think the first time I was here, it was like 10 years ago or something like that. I was at the university, and you pay in crowns instead of in euros. And I went to a bar and said like, yeah, I can pay a few beers and get a pizza and a bottle of wine. Could be like, I don't know, 1,000 crowns, or which also was not a lot of money. But then when I came back and checked my bank account, was like, fuck, this is life in Oslo. Well, my other slide very shortly. I'm a freelance dev. I'm originally from Spain, from Madrid, but I live in Munich, in Germany. I'm part of the Google Developer Expert crew. This is my Twitter account. If you want to ask me anything, I will post in the slides later as well. First, how many people here uses machine learning or AI? Hold your hands. How many people use them on production? Okay, 1, 2. I saw this tweet from, I don't know if you know, I'm a developer in Twitter. He posted the same thing, like, seems to be one of the things with machine learning. We all devs download the framework and start running the samples and see how cool is this, look at this thing with the real-time recognition, and then we find some problems to use it on a real app. This is another excerpt I found in Twitter. I think it's also very relevant of artificial intelligence and machine learning. Before we had something called algorithms, or something called if-else. And now we call it artificial intelligence. You know, this thing like if user this is, I think it's one of the biggest misconceptions with artificial intelligence and machine learning, that when we don't know what's that, then we tend to confuse the description of them. I got this excerpt from a book called Super Intelligence. If you haven't read it, it's a really nice book. It starts, well, it goes a little bit farther. So once this super intelligence will happen, when machines are able, to think, not as they think now, but be superhuman and be more than human at some point, how can we deal with this situation? How can we prevent it? It's a really nice book. Elon Musk talk about it in a couple of articles. They have this excerpt. As soon as it works, no one calls it AI anymore. So when something is obscure, it's AI. Look at this magic, this machine learning, but then maybe underneath there is not that complexity. There is a real explanation for that. So my third contribution to classify the buzzwords today. The artificial intelligence is the science of making machines smart. So we can have a machine that creates music. We can have a machine that translates language. We can have a machine that is able to identify objects. That would be artificial intelligence. Machine learning is the art of building machines that can learn, or making machines learn. So we give them, this is a complex topic as well. We could have supervised, non-supervised, where we, for example, give them some input, they learn from this input, and they develop the knowledge we initially give them. There is also one field that I think is very interesting, the semantic analysis, where you feed a machine with some initial seeds of words, and then they connect to Twitter or any other social network and start learning a language, and if this language is positive or not, and if people is talking about happy things or sad things. And neural networks, which is one of the hot topics, is one algorithm that is used in machine learning and follows a little bit the mental model that we humans have in order to learn things, this parallelism between different nodes. I found this somewhere in Twitter as well, and it's also a sort of classification of a few of the things I have been saying. So artificial intelligence, some examples would be the autonomous vehicles that are driving now, the human-like conversations we have, examples in machine learning. Well, typically this example where we provide a lot of images and the machine is able to learn this is this type of object or this other one. Machine learning can also be used to learn languages. And then we have the rule-based decision making, which is these all algorithms we have, which is or should not be considered artificial intelligence according to this definition, and statistical reasoning, which is kind of a predictive behavior based on or predicting the future or future actions or future output based on a previous history. How many people have worked here with neural networks? Okay, more. In production? Nah, just kidding. So I'm no expert by no means in neural network. I think I programmed a few when I was working at the university, and now maybe just to learn a little bit how it works, the new ones. Basically, on a very abstract level, would work like this. You provide them some examples, positive examples or of images you want the neural network to learn, and they will start finding little patterns. Obviously, you have to provide a lot of training, like thousands of images, millions of images if your problem is complex. And then the neural network is able to say, okay, this corresponds to this pattern. I'm identifying this object. It's something that so far has always been like very good for university studies, but never moved really into production. Since a few years, it's actually making this jump. Those are a few apps from Google that actually are using machine learning systems, or they have machine learning systems. If we go to the Google search, they have this speech recognition. They have the entire search ranking, which is not an algorithm. It got very complex over time. It's not anymore like your link from this website. Now it's really complex. If you go to SEO websites, and some of them have a better description of how it works. Yeah, in Android, you have also the speech input. I don't know if you guys know the Google Assistant. Now you have Google Home. Yesterday, I think they announced the small one. That's an entire system that is connected, and it's able to identify your voice. And it's very funny because you can talk with the Google Assistant and the Google Home and say, hey, who's Barack Obama? Blah, 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 blah. When was he born? It has this kind of connectivity between phrases where it can learn. And it's also amazing because Google is pretty much, when we talk, making it smarter by learning of our questions and answers. Google Translate has also got much better pictures. Talking about pictures, this is an example I would like to show that's from my phone or from my emulator. I travel, I take some pictures from time to time. And for example, in the Google Photos application, if I would like to find pictures of Japan, I could just type Japan. And then suddenly I get a lot of pictures from Japan. This is not because the pictures are geotagged. It's because Google Photos actually goes and says, okay, this is a shrine, or this is, I don't know, like some sushi or whatever. And I could identify this as a picture that came actually from Japan. Another example, I took this from my phone as well. If you guys use Inbox or the Gmail app, you know that you have this smart answering, where based on the context on the email, you get proposed a few answers that you can directly use. So this is an example where Hampus wrote me, do you want to come to the dinner? And maybe it goes a little bit fast. And it says the automatic answer is like, I'll be there, I would like to attend, so I will not be able to make it, automatically, just by reading the email. Another one here, when a guy asks me if I can answer a few questions for an interview, and it says something like, yes, I do, yes, I have time, no, sorry. So it's very contextual learning from the messages you're displaying. This is right now 12% of all the responses on mobile. And as you can imagine, this is growing. Machine learning in Google Translate. Before Google Translate was terrible, not so long ago, I remember in a website, in Reddit, people was making examples of translating from English to Japanese and then from Japanese to English, the same sentence, and had nothing to see. Like, the car is red, and then the other thing was like, my girlfriend is having a dinner. And before, they used to have a phrase-based translation system. So you want to translate from maybe English to Spanish. You could translate first from English to French, then from French to Spanish, because there is a tree and the tree is closer. And that was an example here, translating from English to Chinese. And where will the restroom, can understand it, but yeah, don't expect a lot of accuracy here. And now the new app is using a neural network. It's learning from you. If you know, you can also correct it. So they've been having a lot of user input. And this could be the last result with the last Google Translate app. So as you can see, in this case, it's perfect. It's not always like that, but it's a progressive and impressive progression since the last versions we had. This is a video that was not so long ago presented by Google. I don't know if you guys know this feature, where you can take a picture or a live video, and they translate on real time the the text you're capturing.
1, 2. And flip it. Nice.
I think it's particularly impressive because they even keep the font and the color of the text. It's not just that the translation happens somewhere else, they make it fit within the space, and they have a lot of learning for, okay, you have like 2 lines, but we need 3 lines in these new languages. And this is something that has been done also with machine learning. That sort of example. And well, also there are also a lot of use cases in mobile. I don't know if you guys have one of those watches. I have it and I use it a lot. One of my main use cases is to avoid taking my phone, because before I was taking my phone, do I have a message? Yes, no, you have this phantom vibration that you think is happening and it's just your leg. And for example, if you use Hangout, I use it a lot. When you get a message, I can just scroll and it presents you automatically all these options, like inbox. So it's very comfortable because I might have something that is urgent and I don't need to go and take the phone out. I just can say like, okay, later, no problem, and have all these different options. That was an introduction. Now, let's see why. So we have the machine learning has been applied on the cloud, but this is about mobile. Why would we use machine learning on a mobile platform? It seems on the cloud will be faster all the time, and on mobile not. There could be some considerations where first is that, or the traditional approach was we have our model, and in order to identify it, we make it a request to a server, and through a REST API, HTTP, we need to send the image, the content we want, and then get the response back. That takes obviously time, right? It's not going to happen immediately. So if we want to achieve something like in this video, that would not be possible because you need to send it, and we have also some apps I will show later when you can point out to the environment around you and you automatically get all the detection. So it's much faster and you have a way less traffic as well. It could make sense depending on, obviously, always on the problem you're trying to solve. And yeah, obviously we have motion sensors on the device. If that's something interesting for, or we need to use them in order to apply a solution, we could also benefit from this. And for that, Google released TensorFlow recently. I asked before for how many people had experience with machine learning. Now, how many people have experience with TensorFlow, either on mobile or the cloud? Okay. So TensorFlow is an open source library for machine learning. Right, today is the most popular machine learning framework. Before there were a few, but I think they were not, or they didn't offer that a good experience. This is the URL if you want to download it. And you can train on Mac or Windows. You can use a GPU server to train your models, or you can have it on the cloud. Google has something called machine learning cloud service where you can make all this training independently. And the prediction or interpretation of models works in Android, iOS, and Raspberry Pi if you use Raspberry Pi. This is a benchmark. CFAR10 is a benchmark with that uses some models to see how fast they actually get trained. And you can see here a comparison. On a MacBook Pro, it takes 21.6 hours. Something very interesting here is that we need 16 CPUs in order to achieve the same time as one GPU. So I was also had the same idea, like, I just have a very nice desktop, I will train it there. But if you can have a dedicated GPU, it goes way faster. It's specialized in this kind of operation. It's also used by, those are the partners that Google is working with. So it's Airbnb, I think, is has something on the app as well. So it's something that can actually be used in production. There is a developer advocate from Google called Yufeng, and he has this concept on from training to app. How can we move into an idea to creating my own app that can read or get these models that are trained and try to see in a real world if they work. This is his Twitter account if you want to follow him. So the first stage, we need to train to train the data, we need to get a lot of data, a lot of pictures, positive examples. How would you think we could do this? Does anybody have any idea? Something very simple. We could just use a video recording something. This is a basic example. One background, one light condition, and I just go on different positions. But if you want to train a model to recognize a cat, you could just follow your cat all around, because a video at the end is a lot of frames together. So if you record like half an hour of videos, you have already a few thousand frames that you can use for training the model. So that would be an idea. You obviously, as I said, would need to check, probably train it in different backgrounds, light conditions. If you want to train cats, maybe like different type of cats, not only one. Or if you could train only one, if you only want to detect that kind of cat, for example, a cat that is black. So that would not work with a cat that is white, for example. Then when we have all those images or all this video, we could use FFmpeg. It's a free tool that takes all the video, takes every individual frame, separates it, and puts it in a folder. So we would have already the training input we want. And well, that was the traditional approach. We could have upload everything to cloud storage, and then later use the cloud, the machine learning cloud engine, which says basically, okay, go to this bucket in my cloud, take all the images and generate a model for that. And in the cloud you pay per time consumption or per, depending on your plan, per processing unit, etc. Then, so this process of training actually is complex. I would like, this guy also provides this metaphor to understand it, and I think it's very accurate. You guys know Escher, the guy that has this picture, or the guy that made this drawing? It's a guy that makes these crazy drawings where you don't know when something starts, where it has like different perspectives. It's really cool to observe it. And well, let's see that we want to train a convolutional neural network. That's the neural networks that TensorFlow uses to identify this. Imagine this is a puzzle. Instead of pixels, we have our little patterns. We have different puzzles. How would you solve this puzzle? Or how would be your first approach? Probably a good idea would say, I'm going to take the white ones and the black ones, right? I'm going to separate them because I know they have a similar pattern. That would be like pixels in a picture or agrupations of pictures. And we would put it like this. And this picture is a little bit special because it has only like 2 colors or a few colors, but basically on the same grade. In other pictures, we could have like green and red and blue. So we will group them. And then we could start seeing patterns in the image. For example, here we have a roof. If we go even deeper on the roof, we see that we have 2 types, and we can start watching the pattern, right? We have like these things that are like circles, those ones that are like circles as well, and we see this dividing line. So that's a pattern that we can try to find on the individual pieces we have. And from there, we would move in something like this, where we're trying to solve the puzzle, right? We don't try to put like from 0, 0 and making everything sequentially. That doesn't work. We try to find the little pieces, putting them together, leave them apart. Same, for example, here. We have the stairs, and the stairs, we see that they have a hand holder where we put our hands. We have the stairs itself, so it's a clear pattern with rect lines, and the lines get perpendicular to each other and they cross. So it would be more or less easy to find some of the individual pieces that contain those patterns and put them together. We're doing this thing with our mind, which is obviously more limited than a computer to do this. We do it step by step, we check, maybe we miss one. And by doing all these small steps, normally we end up in something like this, which is more or less constructive. There are some things that might be not there because we don't know still how to put them, but we solve them by finding small patterns that we aggregate, put them together, and create the whole. That's how a neural network works. As I said, I'm particularly not super into the details of neural networks. It's very complex. You have different types. Well, Google uses the network they presented recently in the last Google I/O is the Inception 3, and it has 48 layers of analysis. So when we have a raw image, we pass it, and we need to go to all the 48 layers. When you listen 48 layers, if you're not into this world, you say, I don't know if that's a lot, or maybe 2 is a lot, or maybe... To put it into context, in 2011, the practical amount of layers was 4. So that's like something really way more advanced than before. So yeah, we train the model, we send the raw images, we get the model. The model at the end is a file with a lot of float numbers. And then we need to optimize for mobile, because a mobile we know doesn't have these computation capabilities. And actually, when we train after TensorFlow, when TensorFlow, this model doesn't work directly in Android. It has a few operations that are not supported. It's thought for cloud or for big computers. So we need to apply optimization. Basically, we need to strip the model. We have this huge file that is a lot of floating numbers, and it can be generally up to 90 megabytes. That's a lot. So it's like a big Whopper in the Burger King or McDonald's. Basically, what we do is we move from 32 bytes into 8 bytes. We strip that part, and we achieve this reduction into 4 times the original size. So we can move from 90 megabytes into 20 megabytes, which is more reasonable. You could think, but don't we lose accuracy here? That's a fair question. But per design of the neural network, it doesn't happen on a 4-level factor. The neural networks are very open to fuzzy input, so input that might not be correct or not. So generally, we get rid of this false accuracy. And Google claimed that the losses of accuracy is really low. It's not something that makes the model stop working. And so yeah, we can move from a model that is 90 megabytes into a model that is 20 megabytes with Inception version 3. And if this is still a lot, we can use Inception version 1. When the model is quantized, that's the process of moving from 38 into 8 bits, it's only 7 megabytes, which is much more acceptable, and still, it works pretty well. Another consideration for mobile, TensorFlow increases the APK in 12 megabytes. Obviously, depending on the APK you want to create, you have to consider that the size is going to get increased. And that would be how we move from training the data into the cloud into the mobile app. I also want to put another consideration here. When we have our mobile app, we could decide 2 things. One is to deliver the app with the models inside. That means we upload the entire APK to the Play Store, and then we can download everything together. That way, it would be heavier and have a higher size. Some people claim that this is good because of security reasons, which I think is not the right answer, because if you have a device that has been root, you can download the APK, access directly to all the files, and the model is not protected anymore. But still, maybe you could use some kind, because at the end it's numbers, so you could maybe use a system where you apply some obfuscation to the model, etc., whatever. Or another option would be to download the app reader without any kind of model. So it would be like these 12 megabytes plus the size of your APK, and have the models stored somewhere else. You could store them in Firebase. I don't know if you guys know Firebase. Or Google Storage, Google Cloud, Amazon, whatever, and then download the model on a demand basis when you actually need it. You obviously need to build this system, but could be another option. You don't need to put all the models at the beginning. About the TensorFlow community, it has 10,000 contributors, 22,000 commits, 18,000 repositories with the name TensorFlow. So it's really a very growing and glowing community. There are a lot of resources, and it's actually very active. It's easy to find tutorials and new things. It was not like a year ago where we didn't have the one for mobile, and it's really growing. Yes, this is not something that you can use to fully argument something, but I like to present it as well. It's growing parallelly with the interest on machine learning, and we see that right now it's probably on half. So it's a significant part of the machine learning world. Now, how to build with Android Studio? Google claims that this process is easy. I don't agree with them. We need to use Bazel to build. Bazel is a build tool. According to the instruction, we need to put the binary location in this folder here. We need to add the project to Android Studio, not the beta, but the stable version. We need to install Bazel first. The only version that works is 0.6 because 0.5 breaks and 0.4 breaks another thing. If you Google, you can find these addresses. Some considerations: if you need to download Android SDK at least 23, it works with higher versions, and Android NDK at least 12B, but you have problems with 14 and 14B, I think. So And I recommend it absolutely to do it with the Android SDK manager, because I used to do it manually to maybe have like different NDK versions in different folders, but it's a pain in the ass because you need to maintain this class path and path, and here keeping this version equanimity, it's very important. You also need to modify a workspace file that comes with so everything I'm saying, maybe I say it in 5 minutes, but to me the first time took me like 2 hours because I was having trouble everywhere. You need to put your path of the Android SDK, the path of the Android NDK. You need to run baso with this command to create the demos they have. And then you need to install the APK on your phone or in your device. It's a long process. The other alternative would be to just download TensorFlow from G-Center. Like in Grado, we put this line like compile or download this. That's amazing, and it's how it should be. The only problem is that right now they don't support the object tracking, which is bad. It might change in the future. And the conversion between YGB color into RGB is less efficient than using the native library. I'm going to show you 3 examples that Google provides, and then a little bit in the code how we could change it to show another model. So Google gave us 3 samples. One is the classify, detect, and stylize. Classify. It uses Google Inception, the version 3, to label images. We can swap the model very easily. So with this, having this project in our Android Studio, we could say, okay, now use the model we have trained before using the system I explained, and it will work with our model. There is no person label, so it cannot track people, which is more interesting because then we can track any other object. And if we press on the volume up, there are some statistics about the time, performance per frame, etc. This is one screenshot. We're pointing to some Granny Smith, and it tells the accuracy of the object. And I'm going to show you one example. I recorded yesterday with the help of my poor girlfriend. It's a little bit... I wanted to pause it, but I cannot do it from this view. So here I'm going to recognize my wallet, my computer, my notepad, my space key, and a bottle of water. And yeah, it's hard to see up, but here recognize wallet. Here recognize my iPod. That's, by the way, an Android, but okay, you get the point. Here recognize laptop, keyboard, and space key. The fact that recognize the space key is amazing. And here recognizes the a bottle of water. You can actually point that to many objects, and it's surprising because this was a training follow that some guy at Google that said, hey, let's gonna try this model. So sometimes it's like recognizes, I don't know, like a bag on the, or a cat on the, at my house. Okay, that was one of the examples. That's the detect. Here is used to to draw to detect people. Here we see also the accuracy of the model. It draws a bounding box around people, and it's very useful to count objects. If you have one model and you want to see how many of those models are in the screen, this pretty much this demo will tell you with how accuracy you can find it. Useful, for example, to detect cars and stuff with a high accuracy. There is no training yet supported. I guess at some point they will include it. And this is the styling demo. So here, basically, we are pointing with the camera somewhere else, and we are applying a style transfer algorithm, it's called. I don't know if you guys know here Magenta from TensorFlow. Okay, Magenta is a very cool framework. It's a TensorFlow or machine learning framework used to generate music and art as if it would be human. And there has been a few experiments when they use Magenta to create music, and they put some people and say, is this Bach or whoever? And it was like both Magenta models, and they were like, no, I think it's Bach. And the people were discussing like, no, I think this guy is not Bach, it's Max Richter. And yeah, so in this demo, we can record it here. We can use Magenta models, so we can add artwork generated by computer, and we can mix it or combine it on real time. Here goes, by the way, a little bit slow, but this is a Samsung S4. I think that my old phone got broken, so I have this one that is not particularly fast. And for example, this is how it works. I was before at the speaker launch, and you see that you can combine models. So if I click in another one, I can make it up or not, and applies the styling artwork over the object on real time. You can save it. As I said, you can import as many as you want from Magenta or generate your own ones. Then TensorFlow, it's written in C++. Android uses Kotlin or Java. By the way, how many people use Kotlin out of curiosity? Okay, good. So how do we do it? Well, there is a library called Android Inference Library, very similar to NDK. So we can access through a bridge to all the code on TensorFlow, and works relatively smoothly. Before I move to iOS, I've opened this thing here. I was mentioning that you can swap models. So, okay, this is the demo from Google. I have imported it into my my Android Studio. Basically, we have here this this Gradle file. So in this Gradle file, we specify the models we want to use. So let's say I want to use this app to train my to identify my own models. You just need to substitute the models you want here, and you will be able to access it. So it's very easy actually to adapt it to your own needs. Okay, now back to the presentation. Well, if you use iOS, iOS also provides the access to the TensorFlow API. I think the install requirements are way easier, and you just need to have Xcode, the command line tools that you always install if you have to use Git or any other tool. Brio install automake, Brio install libtool, and then running this thing that takes 20 minutes to build everything. But it's as simple as that. It works very straightforward. One of the demos is called Simple. It just loads a model and tells us some information about the model. Very unexciting. This one here is more exciting, the one I'm providing. It's similar to the one we have in Android, and basically we can access to the camera, and here we identify the objects that are inside on real time. So as I mentioned before, for example, if you want to train a model to identify all cats, you could say I need to take pictures of 200 different cats on different positions and stuff. If you want to identify one single cat, you can also do that. As here, we have like tabby, tiger cat, Egyptian cat. They're all obviously different type of cats, even if they are cats. Always depends a little bit on the problem you want to solve. In this demo, we also run Inception on each frame. It goes very fast. Also, I think iOS has one of those things that the C++ code works way faster. You don't need to make this access from Java and bridging. So it's pretty impressive, and the models can also be replaced. We just can go and see, please take this zip file instead of the other zip file. And we also have a benchmark example. In this benchmark, we see how much it takes to make the detection in milliseconds, and how long it takes to load it, which could be useful sometimes to see if our model got very complex or not, and how much time do we need to do this. I'm not going to show about Raspberry Pi, because I'm honestly not so good at Raspberry Pi. I think I only done a few examples. But I would like to provide you a few resources. So TensorFlow, you can go to this address. I recommend you as well to check Magenta. It's this art generation library, art machine learning generation library. And if you're interested, there is this code lab called TensorFlow for Poets. Here you can see some examples on how to train the models locally. Still locally, not sure if it's the thing you want to do, but it's interesting to see how it works with TensorFlow, which is a huge library. If you don't want to do it on the cloud, you can download it, do it on your MacBook Pro, or on if you have a dedicated unit, you can train it there. And from here, I think you can access a few resources of Google as well, where they provide more training for TensorFlow. Well, I think that's everything. Thanks a lot for being a fantastic audience, and I'm not sure if you have any questions or something you want to talk about.
Yeah, I have many questions. But first, I'd like to know, have you looked at the core ML stuff that Apple provides for iOS? They announced WWDC, I think.
Not really. I'm mostly doing Android. I have checked the TensorFlow a little bit. I'm right now working on an app on TensorFlow, but for Android, not for iOS.
But are the models reusable across platforms? Is it a standardized format?
I don't think so. I would say that Inception 3 models, it's my first guess, but I would say they work with TensorFlow. Maybe there are some conversion tools, because at the end, all the models in all the different formats. Also, when there was OpenCV, at the end it was the same thing, like a lot of floating points numbers. So probably there is a conversion tools that come off between hard cascades and Inception and the system from CoreML.
Yeah, because I'm thinking like otherwise it's gonna be a lot of work to train many different models for different platforms.
I think it's the same with the standards. You have 15 and you say, I'm gonna make a new standard that is the best one now, and then you have 16 standards.
Yeah. Are there any questions from the audience?
In order to train models, or in order
to repeat the question so everybody can hear. So the question is why it can't become better? Is it performance related? Why the models can't become better on device? Or?
You mean why?
Like machine learning in general. What's the constraint? Is it hardware?
Well, it's getting way better. If we move at the university, like, I don't know, when I was studying, I made my thesis on OpenCV, and at that time the recognition was not that efficient. Now it's very efficient. I think the bottleneck was hardware, because, well, hardware grows like every year. There is this law Moore, they doubles every year, but also like the requirements doubles a lot. So it's the same thing, like at the end. I think probably was more the lack of a paradigm that allows us to make this parallelism on massively. Because at the end, neural networks work like human neurons, so there is parallelism between them. It's about making a lot of connections, and there was no pattern or no paradigm that we were using to do that. Now we have neural networks, we can have different levels, and now it's growing much better. I think before was this, we were not using something like neural networks. We were using more linear paradigms, and that's something you cannot scale, or you cannot use to keep with a progressive, an exponential evolution of the state of the art.
Other questions? The question is if the resolution of the input images to neural network, how that influences the training.
It could have some impact to detect patterns. Obviously, the higher resolution you have, the more patterns you can access to in more detail. On the other hand, the resulting file might be much bigger because you identify much more patterns. So I think something I have found that something you don't need to make any super high resolution. Something enough from a phone, like taking this video, works in most cases. But again, I don't know, you want to solve maybe something very particular, like, I don't know, being able to detect virus on a very small an image, and the images are very small. In that case, you would need a high resolution. It can have some impact at the cost of increasing the file of the model.
I'm curious, if you like, you mentioned the 30 minutes of cat videos to train to recognize the cats. How much computing power will that take to make such a model? For example, if I put it on Cloud ML, will that cost $20 or $200?
I think I have this somewhere here, these things. So to train, I think I have this. I think this example is to train. Where was that? Yeah. So you have this CFAR. This is a benchmark. This is a set of I think it has like 5 or 6 models to train, and that's how it takes in all the different GPUs or CPUs. Yeah. So for example, if you want to train, like, it's an example, 5 models of cats, yeah, you could use this GPU. It would take 1.6 hours, and it would cost you like $7 per hour, like maybe $10 or something, using the current prices. And this is something that you adapt over time. Yeah. You can do it on your computer. It always depends on the...
Power is cheap. Any other questions?
Excuse me? How is TensorFlow useful for? Well, you can TensorFlow is huge, so that's the first thing. That's only a mobile part, but TensorFlow can be used to train neural networks that detect the speech. that are able to recognize music and match music. Also, I think they had one example for using they had one example for sentimental analysis, I think, where you you put also like some text, can connect to an internet, any source of text or vocabulary, and then start checking if this is positive or negative. So it provides like a lot of techniques into machine learning. I think neural networks is the main one. You have hard cascades, which is another thing, taking into account negative examples if you want to exclude, because in neural networks you normally give only positive examples, and sometimes you want to exclude because it might be very similar. You can use also hard cascades. I think there is probably the biggest component in TensorFlow might be, besides image analysis, also language analysis and language construction.
Other questions?
Hard to say. I don't work there. I also had the same problems. I go a lot to Japan. I spend maybe like 3-4 months every year. And in Japanese also you can have everything in vertical, in horizontal, in the same paper. So sometimes you're pointing and you know what's very chaotic because you don't know. I'm also vegetarian, which makes things worse because sometimes it's like chicken, but I don't know. It's like only the word, which combined with another word makes something different. It's growing very fast, and if you translate like just single phrases, for Chinese or Japanese, it has improved a lot over the last years using those neural networks. This is also the more people use it, generally, the more feedback you have and the better it becomes. Perfect will be hard to have it probably, but close to a good enough level, I think we're on the way. Whether that happens in, I don't know, 1 year or 5 years is. Yeah, you have in TensorFlow, if you go to this TensorFlow for poets.
What was the question?
If you can train in different computers, like make distribute training. Yeah, there is TensorFlow has a tool where you can specify the nodes. In Linux, I think you need to install locally in all the machines and then make the distribute training, which can be also very useful for huge data sets. Or, yeah.
Thank you for the talk.
You're welcome. Thanks everybody for being here.